Hi, Chem students. We're back. We're going to talk about JJThomson now. We just finished talking about Dalton and his bowling ball model of the atom. The next scientist really to contribute, again, there's a big break in time here, so it's kind of hard to imagine, but 100 years later, basically, this guy named JJThomson came around, and he was a British physicist, and he is credited with discovering this thing called an electron, and that's the thing that we talked about with our sticky tape lab. And the way that he discovered this was using something called a cathode tube ray that I'll explain here in a second. But a cathode ray tube, oops, where's my diagram now? Here it is this basically stream of electrons. They found out that if they took this tube, they filled it with certain types of gases. They ran a charge between two metal plates, and they actually got this this basically kind of greenish-looking light to appear. And so they had like a negative end, positive end, and they found out that they had this stream. And they didn't know what it was, and so this guy named Thomson, when he was kind of working on this thing at the time, I think it was called a Crookes tube. What his experiment was is that when he turned the power on, he made this kind of beam appear. It went from the negative side to the positive side. And he had a feeling that this was made of something and that it's not just kind of light. And so what he did to it is he took this same experiment and then he started to apply a magnet to it. So he put like a magnet there. What he found out is that the magnet made the light beam change its place. And so he found out that these moving pieces had a charge on them. Or at least that's what he kind of made the assumption of, because they knew that light didn't change based on magnets or an electric field or any of that kind of stuff. So there's got to be some kind of like little particle in there. And through some very careful calculations, he was able to figure out that these particles were actually much, much smaller than an atom. He was able to figure out, okay, if this is what the charge is and this is like how much it gets deflected, he was able to figure out what the charge on it was and what the size of it was and how much mass it had. And turned out it was much, much smaller than what we had known at that point to be the size of an atom. And so what he proposed then, basically for his model, and this took him a couple of years to come up with, is that your atom is kind of like this sphere of positive stuff. And so this positive stuff had all these little negative, what kind of in that day they called them, kind of looked like plums, but they basically had all these little negative charges in this big spherical positive charge. And so he assumed that these negative charges were much smaller than the atom itself, and he also assumed that these things could be moved because that's what he observed when they ran the electrical current from the one plate to another. So they kind of discovered the idea that, and this is the first person to really come along and say, you know what, I don't think that the atom is indestructible. There are smaller components than the atom itself. And so the thing that Thomson really kind of brought, and make sure that you sketch out this little plum pudding model diagram. And this wasn't, again, until basically kind of like 100 years ago that, like, now we go away from that bowling ball model and we get to something that has these little electrons. To put in perspective, again, how close in history this actually was. My great aunt, who passed away a couple of years ago, she was alive in 1906. So I mean, we're talking that this wasn't even stuff that was in the science textbooks yet when she went to school. This is something that was like a very recent. So I mean, we're talking basically kind of like lifetimes of away. It looks, I mean, you look in the pictures and you think these guys are like super old, but this is stuff that actually starts to get into a time frame that is close to what we've been doing. Now, Thomson's model didn't stand for long. We're going to find out a young scientist who was working in his lab next who changed this model within a few years.